been stopped. What happened What to do? Sally?
Yes, dear.
Call me someone who's in charge. I want to talk to them.
Okay.
Why so early in the morning?
Have a seat.
What's the matter?
I don't know what's going on right now. I feel like the earth is shaking. So I want you to do the research, Can you?
Give me some time.
Okay, but I want it as soon as possible, okay?
Okay.
Okay.
Mayor! What happened to you?
Man, I've been stressing out about this situation,
Ha ha ha! Don't worry, we have already done the research.
You already done the research? Very fast, 7 days only.
Yes, and let me present to you the findings.
Where and when?
Let's go now.
Whoa, where did you bring me? Why so dark? Why so dark here?
Oh, sorry.
What is this
Don't worry,
place?
Mayor. We will explain everything for you.
Oh,
So
okay.
you just sit down here and hang on tight.
Oh, okay.
Hello, Mayor. My name is Ling Hou Wah, and I'm from ES7 Group 10, and I'll be representing the Group 10 to present about case study 5 for the introduction. Next. So the objective of this case study is actually to study about radioactive decay, which is to identify the radioactive elements present in the meteor, and also we should present data from monitoring of the radioactive concentration and also perform analysis based on the rate of reaction. This presentation consists of several parts, which are the introduction, problem statement, effects on Lobster Island, methodology, data analysis, and conclusion. So for the introduction for this case study. So on the 9th of May 2022, a massive meteorite has hit Lobster Island. All the residents have to be evacuated due to the meteorite's radioactive nature. As we are part of the science advisor team for Lobster Island, the mayor has assigned us to prepare a plan to rehabilitate the island. The residents can rehabilitate the island again once radioactive levels in the water reaches the safe level of 350 parts per billion. So the problem statement for this case study can be divided into 3. Firstly, we have situation which is Lobster Island was hit by a large radioactive material. Next, we are assigned by the mayor to prepare a rehabilitation plan. And for the safe level, once the radioactive particles reaches a concentration of 350 parts per billion, then Lobster Island can be rehabilitated by its residents once again. The meteor strike has 2 effects on Lobster Island. And firstly, the area in the vicinity of the meteor strike will become radioactive. And due to that, all the citizens have to be evacuated due to radioactive exposure. And based on this case study, the chemical concept used is the half-life concept, which can be defined as the amount of time it takes for half of the reactants in a reaction to disappear. And this equation can be derived from the first order chemical kinetics reaction, which is ln the initial concentration of reactants divided by the final concentration of reactants at a certain time equals to the constant times the time. So we need to find the time it takes. And this half-life equation is not affected by the initial concentration of the reactants, which means that the half-life of the reactants remains the same regardless of any reactor concentration that we use.
Over the past 5 days, we conducted an experiment to study the concentration of a radioactive substance in the water bed. We initially determined that the substance had an initial concentration of 95 ppm. Our goal is to reach a final concentration below 350 ppb to ensure the safety of the island for the living organism. To analyze the data consistently, we converted all concentration values to part per billion ppb, the SI unit. We collected water sample daily and measured the concentration of the radioactive substance. The recorded data was then used to create a graph showing the relationship between lone A concentration and time. By calculating the gradient of the graph, we obtain the rate constant K for the first order reaction. Using the obtained rate constant K, we apply it to a half-life formula for a first order reaction, which means T equals to ln 2 over K to determine the half-life of polymer 210. Now, armed with the important data collected over the 5-day observation period, we can use the first order reaction formula, which means ln final concentration equals to negative KT plus ln initial concentration to calculate the time required to restore the island to a safe concentration level suitable for living organism. For a more comprehensive analysis of the data, I will now hand over to my fellow scientist to provide a detailed explanation.
So, this is the data analysis for concentration of polonium. This is the normal concentration of polonium, and this is the concentration of polonium after we increase the density of electron. First thing first, all we need to do is convert 95 ppm into ppb, which is we multiply by 10 power of 3, and we will get 95,000 ppb. Next, we need to find the K. We can find the K by using this formula, and we get K equals to 0.0869. To find half-life, we can substitute K into this formula, which is half-life is equals to ln 2 over K. And we get half-life equals to 3.105. Next, to make it up to the safe level, we can derive this formula into this formula, and we get the safe level is 33 days. To make the time shorter, we can multiply K by 2, and we get 32 days instead of 63 days.
Based on the calculation before, the graph form will look like this. The gradient of this graph represents the K. Next, this is the graph after increase the density of electron.
Okay, now we move to the conclusion. Like the slide says, the expected date, the island will be rehabilitated on 10th July. But if we remove the electron by increasing the electron density, the rate of decay will be double, and the time taken to reach 350 ppb will be shorter. Thus, the island will be rehabilitated on 9th June. The result is the island is secured from high concentration of radioactive. Now we go for the extra information. We all use ChatGPT to improve our language. And yes, that's all from me and our group. Group 10, thank you.
So how was it, Mayor?
I like the presentation. I like the idea, all of them. So, when can you do it?
Or if you want the fastest way, it will be the most expensive.
Oh, expensive? No problem. I give you money.
Okay, you. Alright.